All right, so yesterday we started off on graphing some polynomials, which is always easy if they give you the polynomial in factored form. But if they don't give it to you in factored form, then things become a little bit more difficult. To graph any polynomial, it has to be in factored form. For a quadratic, we use man or we use difference of squares depending on how many terms there are to factor it. But for higher degree polynomials, it's not as simple. We have to use something called the remainder theorem, which states this. Let's say you have a polynomial f of x. There exists, well, not necessarily, okay? But if the polynomial has an x-intercept, by has an x-intercept, I mean if it is factorable. If it is factorable, which automatically means there's an x-intercept, then a factor exists in this form, x minus a. For example, let's say your y is x cubed plus 1, and then let's say our divider is x minus 1. So what happens is when you plug this number in here as x, back in here as x, you'll get a 0, okay? So
Mhm.
because it comes automatically in the form of x minus a, for this example, I'm gonna make this a plus. So that means your a value, your x-intercept is actually -1. Just like transformations, the inside of the bracket automatically comes with a minus sign. So if there's a plus sign, that means a is -1. When you plug this in here, you'll get -1 plus 1, you'll get a 0. So again, just to recap, for f of x, if it is factorable, then there exists a factor in the form x minus a. And when you plug a back into the equation, you'll get a 0. So this is kind of how you factor higher degree polynomials. This is called the factor slash remainder theorem. So what we're going to do here is the question simply says determine the quotient. Determine the quotient. Quotient is the thing that's on top. For example, you have 5, that's your divider. Let's say you're dividing 29. This is your dividend. I'm going to mess up the spelling. Dividend with a D. This is your divisor. What you get up top here is your quotient, and what you get down here at the end is your remainder. So this question is asking us for the quotient. To find the quotient, you have to do for a polynomial, you have to either do long division, or if the divisor is linear, okay, this is the condition, divisor is linear, you can also do synthetic. Long division you can do anytime. There's no restrictions with the divisor. You can do x squared, x cubed, doesn't matter. But for synthetic division, you have to have a divisor that is linear. All right, so let's begin with the question that we have at hand. Determine the quotient when this polynomial is divided by x minus 3. So again, your divisor is going to be outside. Your dividend is going to be inside. And here, when you're setting this up, you have to be careful. All the x's have to be accounted for. So let's say 5x squared was missing, and you jump from 3x cubed to 7x. Notice how you're missing the x squared term. So what we do in that case is that we would manually add a 0x squared here. So if a term is missing, when you're doing long division and also when you're doing synthetic division, you have to manually add that in. Okay, you have to account for it. In this question, it doesn't matter because all the terms are accounted for. By that, I mean all the powers, they go down by 1. All right, let's start with the long division. Do you remember how to do this?
I
What goes
think
on
so.
top? What goes on top? So you're asking yourself, you have an x, you want to multiply this with something such that you get 3x cubed. What is this something? What do you multiply x with to get 3x cubed? It's simply 3x squared, yeah? It's not
Mm-hmm.
that tricky. It's 3x squared. So that's what goes up top here. 3x squared. Now you're going to multiply 3x squared with your divisor, one term at a time. 3x squared times x is 3x cubed. 3x squared minus 3 is negative 9x squared. Like that. And in long division, every single time we're going to subtract. When you subtract, the sign will flip. So if there's a minus sign already, that becomes a plus. So 3x cubed minus 3x cubed gone. Negative 5x squared plus 9x squared is 4x squared. Positive 4x squared. And when you cancel a term, as we did here with the 3x cubed, we're allowed to bring another term down. And then you rinse and repeat. What goes up here? What do you multiply x with to get 4x squared?
4x.
4x. So you multiply with positive 4x. So plus 4x, and then you multiply plus 4x with your divisor. 4x times x is 4x squared. 4x times negative 3 is negative 12x. And again, you subtract them. So minus, and then this minus will become a plus. 4x squared minus 4x squared gone. Negative 7x plus 12x is 5x. Then you're allowed to bring the last digit down. X times 5 is 5x. Like that. Final step, 5x minus 5x gone. This becomes a plus. Negative 1 plus 15 is 14. So therefore, the answer to the question, this is your quotient, this is your remainder, okay?
Mm-hmm.
So there's two ways you can write this. So think of it like this, okay? So 26, let's think about 26. 26, let's say you're dividing 26 by 5. 26 is 5 times, maybe I'll use a better number, 36. So the digits don't repeat. So 36 is 5 times 9. Not 9. 5, 7. So it's 5 times 7 with a remainder of 1. Yeah? That's
Mm-hmm.
one way you can write this. Another way you can write this is that 36 over 5 is 7 and 1/5. 36 over 5 is 7.2. So you can say it's 7 plus 1/5. Similarly, okay, similarly, these long division things, you can either write this as your f of x, your dividend, okay? F of x, your dividend is equals to x minus a, your divisor, times q, your quotient, plus remainder. So this would be this form. That's one way you can write this. Another way you can write this is the second form, where you have f of x over x minus a on one side, and that is equals to q plus remainder over dividend. So it'll be equal to q plus remainder divided by the original function. Not the original function, sorry, the divisor here, 1 over 5, like that. So those are two ways you can express this. So in this thing, I'm going to express it using, well, it doesn't really matter. Both of them are valid. So you could say that 3x squared plus 4x plus 5, your polynomial, is equals to x minus 3. That was not the polynomial. Our polynomial was 3x cubed minus 5x squared minus 7x minus 1. That's equals to our divisor times our quotient plus our remainder. That's one way of writing it. Another way of writing it is in this form where the divisor is part of the dividend. So this is our divisor. We do this divided by x minus 3, and then that is going to be equals to 3x squared plus 4x plus 5, our quotient, plus our remainder divided by our divisor. So both of these would be the final answer to this question. And that's how you do polynomial long division. So quick recap. What you could do is you could do synthetic division, which I think is much easier. So let's try solving the problem with synthetic division. So synthetic division, step number 1, only works when? What's the requirement for synthetic division? It has one requirement. The divisor has to be linear. Okay, that's the only requirement. Whatever you're dividing by has to be linear. So you see this is linear, so we can go ahead and proceed. So compare this with x minus a. Okay, what's our a value?
It's 3.
It's 3. Whenever you're doing synthetic division, the a value must be on the outside. And the coefficients of your polynomial, just the coefficients, you don't have to put the x's. The coefficients of your polynomial go in there. And if any of them are missing, for example, let's say your x squared term was completely missing, you'd put that as a 0. Same thing as long division. So all the coefficients. So the first one is 3, -5, -7, -1. So that's the setup for synthetic division. In synthetic division, we always add. In long division, we subtract, but in synthetic division, we always add. So the first step is this. This number here, the first number, always comes down as is every single time. And then you multiply this number with this number. So 3 times 3 becomes a 9. And you add them up. What does that add up to? What do these two numbers add up to?
4.
4. And then again, you multiply this with the divisor. So that becomes a 12. This becomes a 5. What does this number become? So how did we get this number? We did 4 times 3. Same thing here. This number here, you always take the previous number and you multiply it with the divisor.
So 15.
So it's going to be 15. And then you add them up and that's going to be 14. So the first 3 terms here, this is going to be your q and this is going to be your remainder. Since we had a cubic function and we're dividing it by a linear function, we had a cubic function, we're dividing it by a linear function, your quotient must be a quadratic. It must be a degree 2 polynomial. And this is the same answer that we had before using polynomial long division. So you can do whatever you want, but you need to know how to do using both. Because if they give you a divisor that's more than degree 1, you have to do long division. But when when the divisor is linear, then I think synthetic is way quicker, less room for mistakes. Okay, what about for this question? The question is to divide. What do we use? Which method? Long division. Why wouldn't synthetic work here?
Because it's not linear.
It's not linear, that's it, right? So let's set this up. Always have the divisor in descending orders of powers. Both the divisor and the dividend, they have to be in decreasing power, like that. So here you have x4 minus 2x3 plus 5x plus 3. Yeah,
Mm-hmm.
that's the setup. There's something missing in this setup. Identify the mistake. It has something to do with this. There's something missing here.
You need to have like 0x squared.
Exactly. You need to account for the 0x squared, otherwise it's not going to work. You'd have to do this if you wouldn't work here, but you also do this for linear. When you're doing synthetic, you'd also do this. So 3 plus 5x plus, okay, there we go. So now it's accounted for, yeah? It doesn't matter if you make this 0 a plus or a minus, if I'm being honest, because 0 is neither positive nor negative, but plus works out nicely. So what goes up here? What's the first term? So we're trying to decipher what goes up here. And the thing that goes up there is you ask yourself, okay, you take the highest power here, you take the term that you're interested in canceling out inside the dividend there, and then you ask yourself, what do I have to multiply x squared with so that I get x4 on the other side?
X squared.
X squared. So what goes up there is x squared. And it's always going to be the first term. It's always going to be this term. These we don't really care. These things, they only come into play after we've figured out what we need, what the quotient is. So once you have this, the next step is to multiply your quotient with your divisor. So x squared times x squared, x4. X squared times positive 2x plus 2x cubed. X squared times positive 1 plus x cubed, like that. And then you subtract. When you subtract, all the signs change. X4 minus x4 gone. Negative 2x3 minus 2x3, negative 4x3. 0x squared minus x squared, 0x squared. Sorry, minus x squared. And since we canceled out something, we're allowed to bring the positive 5x down. And we're done with the first round. What goes up here?
Negative 4x.
Negative 4x is perfect. So it's going to be negative 4x, and then it'll be negative 4x times x squared, negative 4x cubed. Negative 4x times 2x plus 8x. Sorry, not plus, that should be minus 8x squared. And then negative 4x times positive 1 would be negative 4x, like that. And again, you subtract them. When you subtract them, all the signs flip. So this becomes a plus, this cancels out. This becomes a plus, this also becomes a plus. So then we get negative x squared plus 8x squared is 7x squared, plus 5x plus 4x is 9x. For the last step, plus 7 here. And then we're pretty much done. 7x squared plus 14x plus 7. Subtract them. This goes away. Minus 5x minus 4 is your quotient. Sorry, is your remainder, not your quotient. This is your quotient, and that's the final answer. Cool?
Mm-hmm.
So again, long division, it's not too difficult. You just have to practice a little bit. Let's see if there's any interesting questions. I mean, they're all very simple. It's the same thing. If you know how to do one long division, you can literally do all of them. We can even move out of there. Okay, this question says determine the remainder when you have this being divided by x plus 7. How do we do this question?
You can use synthetic.
You can use synthetic, right? But what you could do actually is you could use the remainder theorem, which says this. You have some polynomial f of x. When you divide this by a polynomial in the form x minus a, the remainder that you get is simply f of a. This is remainder theorem. And then factor theorem just builds off this. And it says if f of a is 0, then x minus a is a factor. And we call this statement factor theorem. So remainder theorem and factor theorem are the bread and butter of factoring polynomials. So this question is simply asking us to find the remainder. Yes, we could do synthetic division. Alternatively, we could just use remainder theorem, which would make it very simple. So what you need to do is you need to look at your divisor. It needs to be in the form x minus a. So what is a?
-7.
-7. And all you do is you plug f of -7. So your remainder will simply be f of -7. So you plug x as -7, like that. So let's see what that is equals to. It's going to be plus, I get -19. And that's going to be the final answer. That's it. Cool. It's
Mm-hmm.
very simple once you know what you're doing. So here's a question for you. We got a remainder of -19, not a remainder of 0. Is x plus 7 a factor of our polynomial? Yes or no? The remainder we got is -19. Does that mean is x plus 7 a factor of our polynomial?
No.
No, it's not. When would it have been a factor? What was the condition? The remainder has to be exactly what?
0.
0, okay? Not any higher, not any lower. It has to be exactly 0. Okay, what about something like this? It says factor this polynomial completely. Can you man this? No, man is only for quadratics, okay?
Mm-hmm.
Man is only for quadratics, doesn't work for higher polynomials. The first thing you want to do every single time is see if you can simply factor this by grouping. By that I mean something like this. So let's see. So from the first two terms, factor by grouping means you factor two terms at a time. So here it'll become x minus 5. Here you can take out a 2. When you take out a 2, what are you left with in a bracket?
X minus 12.
X minus 12. So notice how these two brackets are not the same, yeah? Had they
Mm-hmm.
been the same, you could have pulled that bracket out and gotten this as your final answer. But the fact is that those two brackets are not the same. So factor by grouping doesn't work. Always check for this, okay? Always check for this. Um, so now what? So now here's what we do. You gotta trial and error, okay? You gotta trial and error possible a values. Possible a values into f of x. And the possible a values, they will always be, a will always be a factor. Okay, it'll be a factor of the y-intercept. What's the y-intercept here?
24.
24. What are factors of 24? What is one factor of 24? What's a number that goes into 24 perfectly?
8.
Yeah, exactly. So 8 is an example. So 24 actually has a bunch of factors. Let me list them out. 1, but when you're doing this, the a value can be both positive and negative, so you have to account for both of them. So it's plus minus 1, plus minus 2. It has a bunch. Plus minus 3, plus minus 4, plus minus 6, plus minus 8, plus minus 12, plus minus 24. Those are all the factors of 24, okay? So those are
Mm-hmm.
all your possible a values. So what you do is you always start here and then you check which a value, when you plug into the equation, gives you a 0. So here let's try f of 1. So that's 1 minus 5 minus 2 plus 24. That is not 0. So 1 is out. I think negative 1, there's no way negative 1 works either. So that's out. I'm going to try 2. F of 2. So I'm plugging x as 2. So 2 cubed minus 5 times 4 minus 2 times 2 plus 24. So it gives me an 8. That's not good enough. Let me try f of negative 2. So negative 2 cubed minus 5 times 4 plus 4 plus 24. So negative 2 gives me a 0. What is the factor in this form? Negative 2 gave me a 0. Okay. So what's the factor? What's our divisor term here? Is it x plus 2 or x minus 2?
X plus 2.
It's going to be x plus 2. So that's what you need. Step number 1, you're going to plug in the factors until you get an x whatever. So here we say that because f of 2 is equal to 0, x plus 2 is a factor. And now we're going to do we're going to do synthetic. You could also do polynomial long division, but I'm too lazy for that. By lazy, I mean it takes longer and there's more room to make a mistake. So synthetic is always a safer choice. So synthetic, we are always adding. The first number here comes down as it is 1. And then you multiply your divisor with this number that's down here, and then that's going to go over here. So negative 2 times 1, negative 2. You add these two numbers up. That'll be negative 7. What goes here?
4.
No. Positive 14. So
Mm-hmm.
you multiplied this number with this number, okay? So positive 14. 14 plus negative 2 is 12. What goes here?
Negative 24.
Negative 24. And therefore our remainder is 0. Remember, this is always a remainder in synthetic. The last number is always the remainder. And because it's a factor, the remainder has to be 0. If this remainder wasn't 0, that could mean one of two things. One is that minus 2 is not a factor. That's all A. B is that your math is wrong. Something went wrong when you're doing the division because the remainder should always be 0. So now we have our quotient. What's our quotient? We're dividing a qubit by a linear. It's going to be a quadratic. Okay? We had a
Mm-hmm.
cubic. We divided it by a linear function, so x cubed over x is x squared. So this is our quotient. It's a degree 2 polynomial. So what's our quotient actually equals to? What's the polynomial?
X squared minus 7x plus 12.
Yes. So now let's further factor this. This we can just man this. It's a quadratic, right? Do you need help? What does this factor to? You're gonna use man. What are the two numbers?
-6 and -2.
Hmm. Actually, does that work? No, it doesn't work. -6 and -2 would add up to -8. You only have a -7. So that doesn't work. Try again.
-3 and -4.
That works. So your factor is -3 and -4. Yeah, like that.
Mm-hmm.
So now look at this. So your x cubed term, your original term, is therefore, keep in mind x plus 2 is a factor. Therefore, f of x is equals to your first term, this, times the quadratic term. And that's the thing, final answer. Cool?
Mm-hmm.
So what you can do from this is you can just graph it because you know everything. Remember to flip the signs. A value is the x-intercept. So your x-intercepts are -2, +3, and +4. Your y-intercept is +24. You have a positive cubic, so it's going to start in quadrant 3. It's going to end in quadrant 1. So now let's connect the points to see if it matches up. And when we factored it, all the degrees are 1. Every x-intercept, it's a degree 1 x-intercept. So it's just going to cross it, and there you go. It works out nicely. And that's a possible graph of this. Okay?
Mm-hmm.
So that's the idea basically. If they give you degree 4 polynomial, you just have to do two synthetic division. So how did we factor x cubed? We first checked for f of a equal to 0, right? And then we found it. Then we did synthetic division, which gave us a quadratic, and then we just manned the quadratic for the final answer. X4, if they give you an x4 polynomial, you're gonna check f(a) equal to 0. You're gonna do synthetic. Now this will bring you down to, over here it brought us down to quadratic, but here it's gonna bring us down only to bring down to x cubed. So you're actually not done yet. And then you have to do another check for the quotient, for the new quotient that you obtained. And you're gonna see what gives you a 0. And then again, you're gonna do synthetic. So now to bring it down to x squared, and then you man it. Okay?
Mm-hmm.
So the number of levels, it's above x squared. That's the number of times you have to do synthetic or long division. So if it's x cubed, you have to do synthetic once. If it's x4, you have to do synthetic twice. If it's x5, how many times do you have to do long division or synthetic?
3 times.
3 times, which is a pain, right? Takes forever. So hopefully they don't give you an graph x5 problem on the test because that does take a while. Okay?
Mm-hmm.
But it's the same concept though. If you can do x cubed, you can do everything. X4 and x5, you just have to do synthetic division once more. Not gonna, all right. What's the degree of this polynomial? It's the degree
4.
4, right? So how many synthetic divisions are you expecting?
2.
2. So it turns out for this question, there's only one synthetic division because you can pull out one of the x's. I guess you can pull out more than an x, but you can pull out 2x. So automatically, what's one of the x-intercepts? 0, right?
Mm-hmm.
Because it's going through the origin. And whatever you're left with here, so this is what you're left with inside of the bracket. You have a cubic function. So you're gonna do the check on this one. So your y-intercept is 2. That means your possible factors are plus minus 1 and plus minus 2. So for this one, let's try f of 1. F of 1 gives you exactly 0. Therefore, x minus 1 is a factor. Now we're gonna use synthetic. 1 on the outside. On the inside, we have 2, 3, -3, -2. This 2 always comes here as is, and then you multiply it diagonally. 1 times 2 is a 2, add them up 5. 5 times 1 is a 5, add them up, -2. -2 times 1. Sorry, this was supposed to be positive 2. 5 plus 3 is -3 is positive 2. -2 times 1 is positive 2, gives you a remainder of 0. Therefore, this is 2x squared plus 5x plus 4. And I don't know if that's factorable. I'm going to cheat. Turns out it is 5x plus 2. So two numbers that multiply to 4 and add to 5 is 1 and 4. So then you have 2x squared plus 4x plus x plus 2. And then you can factor this 2 terms at a time. How we do a man factor. Like that. So therefore, the answer to this question will be this times this, that's your quadratic term, times this, that's your factor term, times this, that's on the outside. So therefore, your final answer will be 2x times x minus 1 times 2x plus 1 times x plus 2. And that's the thing, fully factored. And if you really want, you can also graph it. It's a positive quartic function. So we know it starts in quadrant 2, ends in quadrant 1, and you have all the zeros. You have a 0 at a 0, you have a 0 at positive 1, at -1 over 2, and at -2. So now let's connect the points, see if it matches up. Comes down, goes up, comes down, goes up. Everything checks out, and that's the final answer for this question as well.
Mm-hmm.
So again, graphing higher degree polynomials, not super difficult. You just have to know how to do your synthetic divisions. The annoying part is this part, but usually on a test scenario, the first few numbers will work. Okay, you don't have to go too far out for it to work. Let's try this question. This is an important exam question. So to answer this, you need to understand the remainder theorem. Okay, that's it. You just have to understand the remainder theorem. What does it say again? You have something in the form of x minus a. You have a polynomial f of x. When you divide f of x by x minus a, the remainder is f of a. That's the remainder theorem. And if f of a is equal to 0, then x minus a is a factor, and that's a factor theorem. So we're going to use this concept. So when our polynomial f of x is divided by x plus 1, what's our a value?
It's -1.
It's -1. The remainder is -12, right? So R is f of a. Remember, according to the remainder theorem, your remainder is f of a. So all you have to do is, well, the remainder is -12. Let's find f of -1. If this is f of x, what's f of -1? So how do you find f of -1? You just replace the x's with -1, okay? It's easier than you think. -1 cubed times 2 is -2 minus m times -1 squared is what? M times -1 squared is simply just an m, right?
Mm-hmm.
Minus m. What's the next term?
minus n.
minus n minus 2. Yeah?
Mm-hmm.
Now let's come up with an equation for either m or n. So I'm going to move negative m this side, becomes positive m. Gonna move everything else on the other side. So so this becomes 12. 12 minus 4 is 8. 8 minus n. And that's gonna be our first equation. We can't solve this yet because there's two unknowns and we only have one equation. Now let's use the second piece of information that they've given us. They say that x minus 2 is a factor. Okay? If x minus 2 is a factor, what is f of 2 equals to? 0. Yeah?
Mm-hmm.
If it's a factor, when you plug that a value into the equation, you're expecting to get a remainder of 0. That's the factor theorem. So let's plug 2 into the equation. 2 times 2 cubed, well, that's going to be 16. Minus m times 2 cubed, that's going to be 4m. Plus n times 2, 2n. Minus 2, and that's 0. Now, let's plug in m as 8 minus n in here. So we're going to replace this m with 8 minus n. We're going to do a substitution. It's because we're trying to solve a system of linear equations. So 16 minus 4 times 8 minus n plus 2n minus 2 equals 0. 16 minus 32, what's the next term?
Plus 4n.
Yes, plus 4n plus 2n minus 2 equals 0. 6n equals negative 16 minus 2, negative 18 becomes positive 18. So n is 3. Plug that n value back in here to find your m value, which is 5. And there you go. That's the answer to this question. So again, not terribly difficult. You just have to understand fundamentally what does remainder theorem and factor theorem mean. They're kind of very similar, right? Factor theorem just
Mm-hmm.
means that remainder is 0. Okay, let's move on. So that question, very important. Seen this come up in an exam many, many times. All right, let's do difference of cubes. We've also done this before, but it's a good refresher. So we've done difference of squares, right? Very simple
Mm-hmm.
concept, grade 10 concept. Difference of cubes is more of a grade 12 concept. It's very simple. You just have to know how to follow the formula. So what does it say? It says this. If you have something in this form, something cubed, so, and then this bracket, you can say it's A, plus something cubed, you can say this is B. If you have it in this form, the formulas are here. It says you can rewrite it in that form. What's important is that you need to have cubes on the left-hand side of this bracket for this formula to work. Okay, here's what I mean. Right now we have 27x cubed. I want to write this as something whole cubed. What is it? And it's easier than you think, okay? What you do is you just simply take the cube root of this. Cube root of x cubed, well, that's just an x. What's the cube root of 27?
3.
3. So this becomes 3x cubed plus, what's the cube root of 125? 5,
5.
right? Yeah. So there you go. Now, when you're following the formula, you know that your A is 3x and your B is a 5, yeah? We're following this formula. So what does it become? What do we get in the first bracket? If we're using the first formula to factor this.
3x plus 5.
Yes. What about in the other bracket?
3x squared minus 3x times 5.
Okay,
So 15.
so here you have to be careful, right? So you said 3x squared. I don't know what you meant. Did you mean this option one or this option two? Which one did you mean?
The second one?
The second one would be right, okay? The first one is not right. So it's going to be 3x whole squared because it's the entire a that gets squared. So it'll be 9x squared minus a times b, so that'll be 15x plus b squared, so that's going to be 25, okay?
Mm-hmm.
And then you want to further see if you can factor this. Because it's a quadratic, what does our number multiply to? We have to man this. 'No?
Needs to multiply to 225.
Yes. And add to what?
Negative 15.
Negative 15, right? Is that possible? Bigger numbers are always tricky. 225 is 15 squared. No, it doesn't work. No, I don't think it's factorable. Hopefully I don't have to eat my words here. Where did we get that example? It will turn... No, this was a different example. Yeah, no, I don't think that one's factorable. What multiplies to 225? I guess we can try and see this. 25 times 9, 5 times 45. What else? 3 times 75. I'm just trying to see the possibilities here. And none of these combos, right? You see this? So 225 is a combination of 5 times 5 times 3 times 3. And then you want to see the possible combos from these pairs. This is what I got. None of them in any combination. Doesn't matter which one's plus, which one's minus, okay? All of these plus minus will never add up to negative 15 in any configuration, okay?
Mm-hmm.
So therefore, this quadratic is not factorable, and that's going to be the final answer. And that's how you do a difference of cubes. Again, it's not terribly difficult. If you can do one, you can pretty much do all of them. Okay, maybe we'll do this one. It's going to be another tricky question. All right. So here it says factor the expression. So we have a degree 6 polynomial, and we want to treat it as a difference of squares. In a difference of squares, what's the power outside the bracket?
Squared.
Squared. So if we started off with x6 minus y6, we want there to be squares outside of the bracket. What goes inside of the bracket then? Any ideas on what goes inside the bracket? We had degree 6.
Y cubed.
Yeah, x cubed. Okay, now if you use the difference of squares, okay, again, remember what does difference of squares say? A squared minus b squared is a minus b, a plus b. What does this become? See, this is a, right? I'll give you a hint. This entire bracket is a, this entire bracket is b. So then it'll become x cubed minus y cubed, yeah?
Mm-hmm.
X cubed plus y cubed. And now we can use these formulas here to kind of change these into, I'm just using those formulas up there. So minus, these two become plus, and for the plus, this becomes minus, and everything inside becomes a plus. Yeah, kind of. So there you go. That's the final answer. When you do it using a difference of squares. Now let's do the same thing using a difference of cubes. So x6 minus y6, when you're doing a difference of cubes, there has to be a power 3 outside the bracket like this. So what goes inside of the bracket?
X and Y squared.
Yes, x and y squared. Now I'm going to use this formula here to expand these. It's going to be a little bit tricky. So your a, okay, just to make sure, a is x squared and your b is y squared. Keep this in mind. And now we're going to use the second formula here to expand this. So it'll look like a minus b, so it'll look like x squared minus y squared times a squared, so it's going to be x squared squared, so it ends up becoming x power 4 plus x squared y squared ab plus b squared plus y4. Okay?
Mm-hmm.
And then for the final step, you can kind of open this x minus y, x plus y, and then x4 plus x squared y squared plus y4. And that'll be the final answer for this question. Cool?
Mm-hmm.
So what are the similarities? Well, this term is the same. Yeah?
Mm-hmm.
The only difference is when we did it using a difference of squares, we got 4 terms. When we did it using a difference of cubes, we only got 3 terms. But ultimately, they're both equivalent, okay? They're both exactly the same thing because we started off with the same thing. So the final answer also, although it looks different, they're the same thing. And you can verify this by multiplying it out. If you multiply this term here with this term and FOIL it out, you will get this. Cool?
Mm-hmm.
All right, let's just call it there for today. That's the last question for the
Perfect.
day.
Thank you.
See ya.